So I'm just going to do a combined step for the last set of notes because I'm only going to do 3 examples in total. We're going to look at a couple examples that only have a phase shift, and then we'll do a final example that has a vertical and a phase shift. First example. We have y equals sine of x plus pi over 2. Let's go ahead and make our usual list. From this point on, I'm going to start abbreviating now that you've seen the words plenty of times. Amplitude, I just do amp for short. Period, I just do per. Interval, int for short. Phase shift and vertical shift, we'll literally just say PS and VS. And again, for practice, domain and range. Before I actually break down the equation, let's start with the basics. General equation. Y equals a sine of bx plus c plus d. Sine very conveniently makes an S-shaped curve. So we're going to draw our mini graph here. 4 intervals. We have our circle at the origin. Sine actually starts at the origin inside that circle. From there, the next interval, it goes up to its maximum, whatever that number is for that function. Back down to the midline for the second interval. Down to the minimum for the third interval. And back up to the midline for its fourth interval. Creating that nice S shape. All right, let's break down the equation. Amplitude, that's your A value, positive A. As you can see, there's no number in its spot, so again, it's still positive 1. Period, that's 2 pi over b. B in this case is also 1, so it's just going to be 2 pi over 1, or 2 pi. So this would be considered the standard period, an unchanged period. Interval is the period over 4. Our period was 2 pi, so 2 pi over 4, which reduces to pi over 2. Again, that's the standard measurement for that. Phase shift. We will have one. We have more stuff in those parentheses. I'm going to do that work on the side here. So again, I explained a moment ago that phase shift is taking bx plus c and setting it equal to 0. So whatever's inside of those parentheses, essentially. That will give us x plus pi over 2 equals 0. Don't overcomplicate this. Remember, pi over 2 is just a number. Solving for x, we get negative pi over 2. Our phase shift, x equals negative pi over 2. If you were to write a direction with the number instead, remember x-axis moves left or right, negative would be left, so this is left pi over 2. Vertical shift is our D value. We have no D in this case. D is 0. So we'll just write none there. 0 is also an acceptable answer. And again, domain is always the infinities, negative to positive. Range will be decided later. Questions about the information before we make the graph? Okay. Let's draw our axes. Four intervals to the left and the right. Our interval value is pi over 2, so the first interval here gets a pi over 2. From here, I'm going to write out the unreduced fractions at the bottom. We have 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Reducing, we have pi over 2, pi, 3 pi over 2, 2 pi. And then the negatives on the left, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Our graph has been set up, so let's deal with the shifts. No vertical shift this time, but we do have a phase shift of left pi over 2, or genuinely, we're just going to draw a line through this number on the x-axis. So we just go left to the first interval. This is where we're going to put our new starting point. And this time we draw a vertical line to represent that. This is not necessary, but sometimes it's nice to just label some extra stuff. So just labeling that this is the phase shift, again, of x equals negative pi over 2. Just for emphasis, because we usually don't think about it unless it gets moved, the x-axis here is going to be our midline since there was no vertical shift. So I'll draw over that for this example, just to emphasize that point. Now we can start graphing. So according to our drawing above, we're going to start inside the circle. Next we go up to the maximum. That is determined by the amplitude. Our amplitude is just 1. So we're going to go up 1 from there. So this is our next point. Next interval, we go down to the midline. Next, we'll go down to the minimum. Amplitude again is 1, so we're going up 1 and down 1 here. So positive 1 and negative 1 for our max and min. So second interval here, technically our third one, minimum. Back up to the midline for the fourth one. And then we are going to go a little further than we normally do because of that phase shift, so we're actually going to have 5 points to the right. Back up to the maximum for this last point. Then we sketch the graph from there. So on that same note, when we graph the left side, as you can see, we only have 3 intervals. Again, we just need to have 9 points. I have some students who are going further than this to complete the curve. That's completely optional. You just have to have your 9 points. So I'm not going to fully finish the S curve to the left. Going backwards, remember to be careful with this with sine. It is not a mirror. You can't reflect. It goes up to the right, so we're going to go down to the left. Minimum for that first point to the left. Back up to the midline for the second point. And back up to the maximum for the third point. We'll stop it there. Questions on phase shift? Forgot to do the range. Let's do that real quick. We go as low as -1 and as high as +1, so -1 to 1. Make sure you put the smaller number first, then the bigger number. I do have some students still going out of order on that. If you switch them, it will be wrong. All right, let's do another one of those. Second example, we have y equals 3 sine of 2x. Let me fix that. To x minus pi. And the usual list, amplitude, period, interval, phase shift, vertical shift, and domain and range. Again, let's do general information first. General equation, y equals a sine of bx plus c plus d. And again, the mini drawing of the S curve. Going out 4 intervals. Sine starts at the origin, then the maximum, then the midline, then the minimum, back up to the midline. Let's start filling out the list. Amplitude, A value is 3 this time. Period, 2 pi over b. Hopefully you see that b is not 1 in this case. B is actually 2. So 2 pi over 2, which reduces to just pi. Interval, period over 4. Our interval was, our period was pi. So our interval is pi over 4. Phase shift, again, I'm going to come over here to do that work. Once again, you set what's inside parentheses equal to 0. So we have 2x minus pi equal to 0. Make sure you truly consider the whole expression. Some students just get it in their head that they just need to change the sign on the pi, so it's positive pi, and they completely ignore that too. That's going to change it. Solving for x. We have 2x is equal to pi, so adding pi to the right side. Divide both sides by 2. X is positive pi over 2. So our phase shift, x equals, and this is just for emphasis, I'm going to put a plus in front of that pi over 2. Positive pi over 2, meaning this is a shift of right pi over 2. Vertical shift would be added at the end here. Clearly we have nothing in that spot, so there is no vertical shift. Domain again is always the infinities. Questions on the information? All right, let's make our graph. Per usual, 4 intervals to the left and the right. So first let's set up our x-axis. We need the interval to know how far apart these are. These are each pi over 4 apart. So our first one's pi over 4. I'm going to work with the unreduced fractions first. We have 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. Reducing, we have pi over 4, pi over 2, 3 pi over 4, and pi. And for the negatives, we have negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi. From here, we need to figure out where we're starting based on our shifts. No vertical shift, but we do have a phase shift. So I'm going to draw a vertical line through pi over 2. So this time we're actually shifting 2 intervals to the right. From here, we can start plotting points. Sign starts in that circle. Going to the right, the next point is at the maximum. That is based on the amplitude. Our amplitude is 3. So we're going to go up 3 from that circle. So I'm going to put 3 notches on the y-axis. Bless you. Bless you. So there's my maximum. Next point goes back down to the midline. And that's where I'm going to stop my first curve. So as you can see, we shifted right. We're going to have far more points to the left than to the right, but that's okay. Now going backwards, the next point to the left is going to be the minimum, so I'm going to go down 3. For my minimum. Midline for the next interval, don't skip the 0 and go to the next notch. I have plenty of students who do that, especially on the test. 0 is still its own interval. Midline back up to the maximum for the next interval. Back down to the midline for the next interval. Back down to the minimum. And for our last one, we're back up at the midline. And then we draw our curve. Lastly, we have our range, and I more clearly marked the numbers this time. You can see it goes as low as -3 and as high as +3. Questions? We're going to do one more graph. This one will have a phase shift and a vertical shift. And this will be our last example for today. Our last graph is y equals cosine of 4x plus pi plus 2. We'll go ahead and make that list real quick. Amplitude, period, interval, phase shift, vertical shift, and domain and range. General information first. General equation, y equals a cosine of bx plus c plus d. And the general graph. Again, reminder, cosine has a U-shaped curve. We have our 4 intervals. Cosine doesn't start at the origin, it starts at its own maximum. Then it goes down to the midline, down to the minimum, back up to the midline, back up to the maximum. Filling out the list from there. Amplitude, no number in its spot, so it's just going to be 1, standard amplitude. Period, 2 pi over b. 2 pi over b has a 4 in its spot. So that's pi over 2 for the period. Interval, period over 4. That is pi over 2 over 4. We did one of these earlier. Reminder, when you get to this situation, the trick is to just multiply the two denominators together. So your new interval is pi over 8. Phase shift. Going to do that work over to the side. Take what's in parentheses and set it equal to 0. 4x plus pi equals 0. Solve for x, we're going to subtract over the pi. 4x equals negative pi. Divide by 4, x is negative pi over 4. So in other words, we're going to go left pi over 4. Vertical shift we do have one this time. You can see it's plus 2. So that means we're going to go up 2. Domain negative to positive infinity. Any questions before we start the graph? All right, let's make a graph. And we're going to go up 2, so just kind of keep that in mind when you're setting up your y-axis specifically. Give yourself a little more room up top. Setting up our x-axis, we have 4 intervals to the right and to the left. First number is the interval, which is pi over 8. From there, I will work with the unreduced fractions at the bottom. We have 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Reducing, we have pi over 8, pi over 4, 3 pi over 8, pi over 2. Repeat for the negatives. Negative pi over 8, negative pi over 4, negative 3 pi over 8, negative pi over 2. And in a moment, I'm going to figure out my starting point. I know my vertical shift is up 2, so I'll go ahead and mark that on the y-axis. Let's place that circle starting point. We are going left pi over 4 and up 2. So we're going to negative pi over 4, up 2. That's where I'm going to place my circle. And now I will draw the lines through it. I'll do a vertical and a horizontal. Reminder, the vertical line represents the phase shift of x equals negative pi over 4. And the horizontal is the vertical shift of plus 2. From here, we can start plotting our points. So again, we're working with cosines, so we're going to start up at the maximum. That is determined by the amplitude, so we're going to go up 1 from the circle. So we need one more notch on the y-axis. We're going to go up to 3. Starting at the maximum of 3. Next interval, and if it's beneficial, you can also put your tick marks on the actual midline just to help. That's completely a personal preference. We're plotting on the midline from there. Next interval, which is the y-axis, don't discount it, is our minimum. Again, amplitude is 1, so we went up for our maximum. We're going to go, up 1 for our maximum, down 1 for our minimum. So our minimum here is at 1. Next interval, we're back on the midline. Next interval, we're back up to the maximum. Next interval, we're back on the midline. Next interval, we're back down to the minimum. I'll go ahead and sketch this part of the curve. We have 2 more intervals to graph to the left, so I'll do that real quick. Again, cosine does truly mirror itself on the left and the right side. We're still at a maximum here, so we're going to go down to the midline for the first point to the left, and down to the minimum for our last point on the left, and finish the curve. Questions on our final graph here?